Okay, so hello to our grade 8 IT Science High School students. This is going to be our second lesson for the third quarter. We're on areas of equilateral triangles. Now, this topic is very important because equilateral triangles can be found everywhere, especially on a lot of constructions and buildings and bridges. You can find them on the foundations of bridges and also on the windows that you find on tall buildings and skyscrapers and also on houses where you see the window lattices. The patterns that they form, most of them are in the shape of an equilateral triangle. It is also an equiangular triangle. So let's try to find the areas of these three figures. The first one is very easy, it's an equilateral triangle. The second one is a rhombus. And the third one is a bit challenging, it's a hexagon. Okay, so for the first one, okay, given that we have an equilateral triangle whose perimeter is 24, what is the area of the figure? Now, the area of an equilateral triangle, as I have mentioned during the discussion, is equal to 1/4 of the square of its side measurement multiplied by the square root of 3. So this is the general formula. For the area, this is the area of an equilateral triangle. There you go. And since, according to the given, the perimeter is equal to 24, so therefore 3s is equal to 24, we can divide both sides by 3 to get the value of the side of the equilateral triangle being equal to 8. Now the area of the triangle is going to be very much straightforward. So that's 1/4 of 8 squared times the square root of 3. So that's 64 all over 4 multiplied by the square root of 3. So that's 64 divided by 4. So that's 16. So therefore the area of our given equilateral triangle for this problem is equal to 16 square root of 3 squared units, or if we want to use the decimal value of it, so that's 27.71. Okay, so that's approximately 27.71 squared units for the area. Let's try letter B. So for letter B, we have a rhombus. It's not just a regular rhombus, because if we're going to look at it very closely, the sides here, since it's a rhombus, they're the same, and the diagonal, okay, according to the rhombus, a rhombus in which the shorter diagonal has a length of 12 and whose angle and an angle that measures 60 degrees. Now, this 60 degrees, okay, is opposite that of the diagonal. And since these two sides are the same, and since we already have a 60 degrees here, and since we know that the entire interior angle measurement of a triangle is 180, we can subtract 180 and 60 to get the measurement of the sum of B and D. So that's 180 minus 60. That should give us 120. And since there are two congruent angles, we can divide this by 2. So therefore the measurement of angle D is also 60, and the measurement of angle D is also 60. Therefore we will have formed a equilateral triangle. And if that's an equilateral triangle, this is also an equilateral triangle. It turns out we have two equilateral triangles formed on this rhombus. Okay, so how do we find the area of this equilateral triangle? Since the diagonal is just the same as the side, and according to this problem, the diagonal is equal to 12, so therefore the side must also be equal to 12. Solving for the area of the equilateral triangle, so the area of the rhombus is going to be 2 times 1/4 s squared multiplied by square root of 3. Okay, so let's write that here at the bottom. So the area of the rhombus is equal to 2 times 1/4 s squared multiplied by the square root of 3. Since we already know the value of s, so that's going to give us 2 times 1/4 of 12 squared times the square root of 3. So that should give us 2 times 144 divided by 4 square root of 3. And what's 144 divided by 4? So that's 36. So that's 2 times 36 square root of 3, which should give us 72 square root of 3 squared units. So therefore the area of the rhombus is just equal to 72 square root of 3 squared units, or if we want the decimal value of that, so that should approximately give us around 124.71. So that's around 124.71 squared units, the area of our rhombus. Okay, so for the third one, or for letter C, we have here a hexagon. Now on this hexagon, we have a central angle, an angle at the center of the hexagon that measures 60 degrees. And according to the given, it has a side length of 6. It's a regular hexagon. So if it's a regular hexagon, that means all of its side measurements should be the same. Okay? And that means this regular hexagon that we have here, it's also forming 6 equilateral triangles. If this is 60, this is also 60, this is also 60. Okay? And since we have 6 equilateral triangles, again, we can use the formula for finding the area of an equilateral triangle. So that's 1/4 s squared square root of 3. And that should give us 1/4 of 6 squared multiplied by square root of 3. So that should give us 1/4 of 36 multiplied by the square root of 3. And what's 36 times 1/4? 36 divided by 4. So that's 9 square root of 3 squared units. That's just the area of one equilateral triangle. There are 6 of them. So we have to multiply this by 6. And that should give us 9 times 6, which is 54. So therefore, the area of our regular hexagon is equal to 54 square root of 3 squared units, or if you want that in decimal value, so that should give us around 93.53, approximately 93.53 squared units. Okay, so these are the exact values of the areas of our figures. For the equilateral triangle, it's 16 square root of 3 squared units. For the rhombus, it's 72 square root of 3 squared units. And for the hexagon, it's 54 square root of 3 squared units, using our knowledge on equilateral triangles.